Oh, hello, Josh. Okay, so recording is
How's it
started.
start?
Welcome to the meeting.
Hi, World Wide Web.
I'm going to drop the link into the Zoom chat. I forget if that shows up on the recording. Probably not. I'll put it somewhere.
Okay.
So yeah, the Dropbox paper. Actually, what I'll do is share. For those of you who may not have it open. Also,
Oh, wow. That's so much light.
I was going to add a link.
You just force me to be full screen?
Can you draw? Yeah, exactly.
Oh wow, this did something crazy. Hold on.
It's fine.
It's supposed to be smart or something.
Yeah, there's probably, I think there's some integration we can enable, but okay, so I think the plan was we would begin with triage and discussion. I'd like to keep it, ideally, if we can keep it to like 15 minutes, that seems ideal, but I don't know if we're going to be able to with the NLS.
I would suggest we swap the order so that we do the UCG first and then we do the triage. Because I suspect that might take more time today.
Okay, I want to try that. Let's try the UCG first. So I have this write-up that I can kind of, I guess I'll walk through it a little bit and then feel free to interrupt me or ask questions. I don't know how much everybody knows this, so stop me if I feel that everyone does. But so Unsafe Code Guidelines, somebody should mute, by the way. Whoever has a small child talking to them.
Sorry, that was my fault.
It's adorable. Okay, so the Unsafe Code Guidelines, we've been working for some time now, and we've been trying a sort of different way of operating where we have a repository. It has, in this repository, there is, hold on, I can even open it. There is a kind of draft reference, which includes stuff that we have reached some consensus on, and in some cases it includes like open questions. So for example, for structs and tuples, this part talks about the layout of structs and tuples. There's a disclaimer that this is not really ratified in some sense.
What an interesting first example, Nico.
So what we've been trying to do is, because there's so much to talk about, we've been trying to have at any one time an active area of discussion. And this gets proposed by a PR, which describes the area. Like this is Ralph's proposal for validity invariants, talks about some of the goals. And if you actually look at the text of the PR, it lays out like, here are some of the threads that we should, some of the ways to break the conversation up into threads. Then we kind of discuss on the issues. When we reach a consensus, somebody writes that into a PR that edits the reference. And sometimes we'll open up follow-up issues with stuff that still needs to be discussed. We have weekly meetings on Zulip. We mostly look for stuff that have reached consensus and try to make sure that this stuff keeps going. I feel like it's working pretty well. I think the main problem has been, one, we haven't been drawing enough attention to these conversations, and two, we've all been pretty busy. But I don't know, that's my perception. So our general roadmap, we've been focusing on trying to get to a first sort of RFC, and that RFC would cover two things that are kind of interlinked: the layout rules for data structures and validity invariants. So layout rules would be stuff like, an example of something an unsafe code author might want to know is, can I assume that an option of an extern C fn is compatible with a C function pointer, or not? And similarly, can I assume something? What can I assume about the layout of my structs? What order the fields might go in, and so on? What does, not to mention documentation. So we, like, for the case of enums, there were some accepted RFCs, and the text of those is kind of imported into the guidelines, saying like, when you have a rep C enum, it has the following rules. That's one of the few parts of the thing that does not have the disclaimer of not being ratified by an RFC. Validity invariants are more about what have to be true for the types. So, for example, when can things be uninitialized, or must references be aligned, stuff like that, right? So where we are now, we've kind of gone through a lot of the layout, although Kramer or Taylor had a concern about some of the things, which is fine. But the point is we went through and we talked about the different aspects of layout, and we're more or less done. I think we're still mopping up a few lingering PRs, like about array layout. And I kind of sketched out some of what we said here. I can go through it in depth, but I guess I won't at this moment. And we're talking about currently validity invariants. And there we've kind of narrowed down that indeed the boring stuff is boring. So the idea of the boring stuff is, things like structs and arrays, it's fairly easy to define what the invariant associated with it is, because it's basically the union of the invariants of its fields. The harder stuff is stuff like integers and references. And there we have a whole lot of options. So where we are at now is trying to take a lot of the exploration we've done and consolidate it into some kind of write-up summary that will tell us what the different roads we might go down are. I don't think we're at the point where we feel like we have a consensus over very much. Is that right, Ralph?
For these two...
That sound right?
Hello, can you hear me?
Yeah.
Okay. Yeah, for these, the unions are also among the, they're not as bad as integers and references, but also certainly like nothing we have an agreement on. And also, I guess maybe it's clear for everyone, but like the reason these layout and validity are intertwined is because we exploit validity invariants when doing layout optimizations. So like we can't talk about the layout of option bool without talking about the validity invariant of bool. And the question of like, what is the layout of option enum, of option of a union, depends on whether the validity invariant for union says the things it has to say for like layout optimization for unions to happen and stuff like that. So you can't really talk just about layout without talking about validity invariants and vice versa.
Yes, that's a very good point. That's sort of how we came at this this combination. Also,
I tried to tease it apart a bit, and I feel it has somewhat worked, but sometimes it was like, okay, here we really can't disentangle the two.
I think the other thought I had was that layout would be relatively uncontroversial and a good way to get started, but of course, especially for Booleans, the most complicated time.
Oh, no, we don't mention Booleans.
It's been, compared to other things, that's been true.
I can't believe we're not supporting the platforms where true isn't one.
No, I believe we are. Or I don't know. I forget.
Did we decide that? I thought we decided against that.
I forget. Whatever we decided.
The only hard requirement that we guaranteed was that bool will match C. So if C on the platform is just that weird, then we will match it.
But what C? C11, C, yeah.
C of the default platform that we interoperate with FFI.
Whatever we decide the C is, the official C of that platform.
That actually was a relatively uncontroversial area because we had a previous decision. So we ran with it. But so
more controversial was like, what about platforms that don't have C or something like that? Anyway, doesn't matter.
So I guess what I think where the things I wanted to raise for feedback, first of all, of course, we can talk about some of the details, and I'd love feedback on the technical specifics. Although, but also in terms of, I was trying to think of what are the like higher level issues around the process or constraints that might help us go forward. Unfortunately, I don't think we got far enough with the validity invariant write-up before this meeting to kind of lay out, here are some, if we think we would value X more, we might take this direction. But it seems like there will be some questions, like some kind of trade-offs around how many layout optimizations we can do, and compared to what amount of code. So one question might be like backwards compatibility, trying to get a sense for, by backwards compatibility here, I mean, if there's extant unsafe code in the wild, to what extent can we break it and declare it to be UB? And where maybe it works today and maybe it doesn't. I don't know in some cases. If it's a common pattern, right? And I think a mitigating factor there, one of the things we've been trying to stick to and is ensuring that we can dynamically check most everything we say, conformance, especially around validity. Oh, I wrote safety invariants, but I should have said validity invariants.
We need a different word for that.
Yeah, so basically that is a strong consideration for us. That is to say, you could imagine invariants that are very hard to dynamically check that would require you to walk unbounded amounts of memory at runtime, stuff like that.
Deep values references and such.
Right, and we should talk about if that's okay, and if that might mean that in practice people aren't able to do as strong a dynamic check as we wanted, because we would have to do approximations for performance. On the other hand, there are dynamic checks that we already won't be able to do, probably, like if we'd have to like randomize struct layout and so on to really test against all the things. So maybe that's okay. And also in terms of the idea of an RFC, what should this RFC even look like? I mean, should it sort of reference a fixed version of the? I don't think we want to copy and paste all the text from the reference necessarily. But
I have.
So do we actually want one RFC, or do we want multiple RFCs, one for each major guideline?
I
I
think
would tuples. Here is the this. Here is the that.
I think one RFC seems unfeasible.
Can I interrupt this and say, is there someone who would be willing to take minutes or scribe some of what we're saying? Just like highlights. I think
Isn't that what the video is for?
the video is for detailed minutes. I'm just thinking it might be nice if someone would take some notes. But yeah, we can just run with it. At minimum, let's try to focus our conversation. So should we talk about RFCs and what form it should take?
So I think it seems reasonable that there be many RFCs. It seems unfeasible to do everything in one. And I think things would get too sloppy. I think we should be detail-oriented, and one RFC seems...
Can you define a sample scope of an RFC in your mind?
So it would say only deal with tuples, say.
The problem with some of that is that the discussions are interleaved.
Sure.
Like tuples with structs and then homogeneous with arrays.
I think that's true of a lot of our RFCs, though.
Yes. So you will need to find something that is not too big, but also independent. Can be proposed independently. That is hard, but that would be ideal.
But one advantage of the setup we have now is that by the time we get to that stage of the RFC, we can, of course, point you at, like, they are interleaved, but we can also, the whole is present, right?
See, that was what I thought about. That was what I thought about the futures discussions, and that I could just point people back at all the futures RFCs and the issues that we'd had where we'd made all those decisions. And it turned out that people didn't want to go read those, and they wanted them to be in the RFC and to discuss them all on that thread again. So
I think there is a difference between having to sort through an unstructured number of comments as opposed to a structured document which has a table of contents and...
so Central, now you're saying that it would actually be okay to have it all as one RFC? Is that what...
No,
if
I
you're
think...
referring to the table thing, I mean, it's like if there would have been a link to a coherent write-up of that, that's external.
Yes.
Nobody would, I think, but like I have not seen such a thing anywhere.
We're actually talking about slightly different things, I think, if I may interrupt. Like, I think Taylor's talking about, or there's one thing which is justifications and alternatives, like detailed coverage of how a decision was reached. And there's another that says, well, when we're talking about the layout of structs, we have to refer to the layout rules of the validity invariant rules. And that might be a separate RFC, but we do have, like, there is a place you can go to see all those pieces.
I think both is important. So I was going to bring that up. One thing that I find lacking in the current documents is the what is generally well described. The why isn't. like if we're going to, as a line team, make decisions about different
Right.
things, it should.
And similarly, the why
this.
exists in issues, right? And discussions that is not structured and isn't written up in a single coherent place, which is
right.
what I was.
And I think that needs to happen.
Yeah, I quite like this. This also fits with, I would just like us to shift as much as possible to producing these sort of artifacts, these good summaries and detailed accounts of the trade-offs, so that when we come back and we can read, we can have them. I'm trying to think how it would fit. I think we should have a reference, and I think we should have probably links some way. I don't know how they should exist, these write-ups, like I think they should be in the repository. I'm just not sure where to actually put them, but I guess we can sort that out. So.
You could plausibly have a series of RFCs that are not proposed, like that are proposed at once but are separate.
One other thing I want to emphasize is that I don't want a situation where we are. I guess this isn't that dangerous, but I'm concerned about a lot of input coming in very late after a lot of work has been done to produce a coherent whole with a lot of links. I would much rather we are bring attention in. Just isn't to say we shouldn't do RFCs. And I think if we've done a good job, the RFC should be pretty robust anyway.
Yeah, I agree. It would be good to produce the what and the why simultaneously. Like you can draft RFCs and do them incrementally or whatever form the why document takes. It doesn't have to be the RFC structure. I think the important thing is that the why exists in a structured form.
Yeah, I agree. I think the why so far actually would mostly be a why not. I don't think we need to explain why union fields start at offset 0 when it's repr C, but it might be worth explaining why we don't guarantee them to start at offset 0 when it's not repr C or something, right? Most of the time, the things we are saying happen is like the one and only obvious thing that could happen. But then there are all sorts of things we don't guarantee, and that's where we might have justification for what we don't want yet, but some of that is hypothetical, and it's more like we want to keep doors open and stuff.
I think it should be justified why guaranteeing some layout is useful, because there's usually always the if we don't guarantee something, it might make language design or something else easier in the future.
Seems fine.
Well, but it's quite clear that it's useful because people want to transmit stuff around and things like that. I don't know. I find it much more interesting to discuss why you wouldn't want to guarantee something. But I guess this just
seems like both are good. We can describe why pretty easily, right? In most cases, that's fine. Say they are compatible with C. It sort of explains itself.
Yeah.
But our RFCs usually don't take the form, why not do this?
So,
but this is about. In the issues, the unstructured part was mostly about figuring out which part of what rustc currently does is guaranteed versus could change. So
Sure.
So if the only why we really talked about so far was the why don't we guarantee this.
Yeah, that seems like a good start. But I think we should also say why we guarantee this. What are the risks for optimizations and for future language design?
It seems like what you want is sort of like a pro-con list for all of the things that you guarantee, or for everything, for anything that you could choose to guarantee or not guarantee. Specify what are the advantages and disadvantages of each option. Right?
Yeah, basically.
As an argument for why documenting why actually is important is that I'd say it's not actually trivial to infer whether the motivation is for ABI passing in the function call versus transmutation. These are two different use cases that have different constraints, I think, and thus it's worth documenting which one's intended.
I think we should basically have a reference and a justification, which mostly has the shape of an RFC. But I'm not entirely sure about that point, because I think these things might evolve, and we want at any given time, we want to be able to go back and look at what is the like combined result as well, perhaps as the individual decisions. But I think when we're looking at struct layout, if we've done, let's say we have the first RFC for how you do structs, then down the line, we say, okay, we're willing to guarantee the layout in more cases than before. That's another RFC, but I would ultimately like to be able to go find the justification for the union of all the things. And so justification and a reference, and basically have them hyperlink to one another, like with footnotes, essentially saying, this is why we did this. It was written here. The right. I like that.
But also, not just justification. Not just justification. Well, you can call it justification, but it would also be useful to have the drawbacks and the cons as terms.
I assumed that was part of it, but
yeah,
I'll put justification and drawbacks. Sorry, Ralph, what were you saying?
I would have actually expected it to be more like the reference like contain the justification. Like having two parallel hierarchies sounds rather annoying to maintain, and to have to jump back and forth between.
I leave that up to you. I just want the information to exist. I don't. It's not a big deal how you structure it, as long as information exists in a structured way.
I think that's probably right, Ralph. I didn't necessarily mean two parallel hierarchies, but I do think you'll want to have a certain amount of specification and then a certain amount of justification for the decisions. Like it won't be, you can't every other sentence interleave back and forth, or that might be annoying. But they might be within one file, for example. Might be like at a per section level. I don't know. We'll play around with it.
Section or something like the folded part with the justification that you can unfold. I don't know, something like that.
That was, that's what I had in mind, actually.
Block quotes or something, I don't know.
Right. I imagine people will want to, we can also play around with like producing multiple outputs, right, that have different amounts of material. You could do like that annotated Linux thing where you have you have like the source code on one side and the comments on the other.
Like columns or something?
Yeah, I guess people have no idea what I'm talking about. I have a book, which is a printout of the Linux kernel from like 2003 or something, and it has the source code on one side and then like lots of text explaining what's happening in the second column, and it's very cool.
That makes sense.
I've read that one. It's great.
Yeah. Okay, I feel like so we're going to try to produce these things. We're going to produce granular RFCs. I think I'm not entirely convinced about the granular RFC, but we can revisit that. Like it's going to be a lot of things at once, either way. Maybe the answer is we should do some sort of like, the RFC should be to kick off series of
the thing I really want is
examinations of each point. And then,
the thing I really want is a large RFC that is able to have threaded conversation, which is the thing that I want on every RFC.
Right, so, well, that's sort of what we're doing live, right? But trying to do.
Yeah.
But I was thinking maybe the answer is, in any case, what does an RFC even mean? There's not like an implementation period. Maybe the RFC should be something where we proceed and we do a final examination. The RFC is that we're starting to do this process of, okay, we think we're at a good point. We'll go down piece by piece and revisit them in detail. And the stabilization is, we've done all the detailed examination and the whole seems to be coherent. We're done.
Well,
anyway,
there may be actual implementation changes needed, or something, some addition to the language. Like if you don't want to guarantee something, maybe you want some sort of opt-in which does guarantee it, like transparent or something.
Or maybe you want to have
a good question.
Or maybe you want to have a flag that randomizes it for testing and stuff.
Yes, so you're absolutely right. There may be supporting changes that go along with it. And one question we have had from time to time is, when we see a need, like an optional feature or a flag, what should we do? An example that may or may not be one that you find compelling, but might be, okay, there's no way presently to say that the layout of a given struct is linear apart from repr C, which has other repercussions and that you may or may not want. We could identify places where it would be useful to have more options. necessarily think it's the role of this working group to, I don't know. I could imagine us opening RFCs about those changes, but it feels a little different than the documentation work itself.
You could identify the needs, I guess.
Yeah. Maybe that already just feeds into our evolving working group structure. Like,
yeah.
For example, reprilinear might be FFI or some other kind of interop question.
I'm personally more inclined to specify as little as possible about repr rust and have opt-ins. That's just me.
No, I like this. I mean, I don't think we've been very disciplined about that so far because we weren't really sure what to do about it.
Great.
So it's 3:30. We still have some time. What were the other questions?
Dynamic checking, I think.
Yeah, that was something I wanted to bring up.
And something about unsticking and what the next area to focus on is, at least going on the points differentiator and places for feedback. I think we discussed what form artists should take, but not so much the other things.
These are the things, right?
Right.
This one, I would like to hear, Taylor, what you have in mind, although I think it's probably better done outside of this meeting. But
yeah, I'm fine either way.
But I guess we'll see. But dynamic checking, I don't know, Ralph, maybe you want to say how the way you've been thinking about it. I think we've been taking as a given that, oh, you know what the other area was breaking changes, which is, in my opinion, interconnected with, that's a somewhat weighted terminology, but
yes.
I think we've been taking it as a given that that we want to do better than C, and we want to be able to give people a way to dynamically test their code and get a reasonable level of confidence that they do not have UB in their tests. Yeah, as I said, it probably can never be perfect because if for nothing else, then any given test run only exposes some of your behavior.
Yeah, I mean, I guess you're all aware, I guess most of you are aware, this is something I've been working towards with Miri. And besides what Nico already said about this being useful for programmers, this is also extremely useful for researchers that want to do something with Rust, because this is a dynamic checker for UB that actually exactly characterizes UB is exactly the kind of artifact or thing that you need as a researcher to do proper verification about anything. And one of the reasons that this is so hard for C is that there is no such thing. So it's there's some long-lasting benefits from that. Of course, for the research part, it doesn't really matter how efficient this is to implement. It just matters that it can be implemented in principle. And the current thing that we have is that Miri can check some things, and it'll never be able to check everything. And in particular, at some point, non-determinism will come in, and then if your correctness of your program depends on which addresses memory allocators pick, well, then it's always going to be a guesswork.
So
there's a lot of value in being able to at least in principle, and also then as many cases as possible in practice, check that small, medium-size-ish programs and test suites actually conform with the UB specification.
And that would be mainly useful, the performance aspect would mainly be useful for average users or average users on Unsafe, as opposed to researchers.
Yeah, I mean, making this actually feasible is useful for somebody who wants to run their test suite, as opposed to firing up Coq and proving it manually, which is most people obviously are not going to do. Right. So for the vast majority of people, the usefulness of this hinges on the fact that you should actually be able to run it practically and not just in principle.
So a couple of thoughts that came to mind while you were talking, Ralph. First off, I just wanted to point that I at least I'm still super excited about doing this eventually in a bigger context like Valgrind or some other tool. It doesn't have to be Valgrind, but ASAN, something that runs with real C code and so on, arbitrary code. And I think we've been trying to design things so that will work. But it occurred to me that actually I said there's no implementation from this work, and Central correctly pushed back, but you could push back even harder by saying, actually there is, which is the dynamic checker. Maybe it doesn't apply as much in the layout section, but it certainly applies in the dynamic verification.
Also, some definitional interpreter or something. Well, much later work.
Like Miri is an artifact that exists right now, and so far I haven't done any changes following these discussions, but that's mostly because, like, in the cases where we are all in agreement, Miri already does the only obvious thing. So that would actually be an artifact of this working group, yes.
So my question would be, what are the main blockers for, or where are the areas of concern for performance? I understand references are one of them.
I mean, I haven't done a study of why Miri is slow. Stacked borrows is like, I mean, it's crazy slow, obviously. Like there's all these, every single reference assignment, like writing x equals y, where x or y are like struct types containing a reference. There's all sorts of extra walks over memory, and there's huge data structures, and it's completely ridiculous. I mean, I was not concerned with performance at all when I did stack borrows, so it's a huge thing.
Right.
And of course, the validity checks mean that every single assignment also walks over the value that gets copied and make sure that, like, oh, this like 8-field struct still is like consisting entirely of booleans or something. I just checked it. I'm going to check it again because I don't know that I already checked it. There's probably lots of low-hanging fruit there. But in terms of some of the things we've been discussing, if validity checks would have to actually recursively walk references instead of just doing a shallow thing, that of course could be a huge, will probably, well, I don't know how deeply nested reference structures we usually have, but for those it would be a huge cost.
I mean, that also
and it
seems
would
like
also
something
be
you could make configurable, right?
yes, but if you configure it, then you would lose precision, right? It would it would mean we wouldn't be able to efficiently check the full UB, just an approximation of it. And of course, it'll always be an approximation, but
Right.
this would be yet a corner where it would be more approximative.
So here, I think you said you don't know how deep our reference structures is. That seems like something that would be good to find out for the purposes of deciding this. Like on average.
I was just thinking of a related thing, which is, I just want to throw in there before I forget it, which is that it also might be a means for us to test or like to answer how important these other invariants are or so on. If we could run the test in both modes and see like how much additional UB did we detect in one mode or the other, it just seems like useful data to have a notion of. It turns out making a recursive guarantee, validity invariant doesn't, if it's exactly the same set of failing tests as a non-recursive one, I don't know exactly what that means, but it seems relevant to the final decision.
The one thing I would find really weird is if we had some sort of one level deep. I think it should be either fully deep or fully shallow. That's my personal view.
I actually would be fine with it saying like, oh, it's 5. Like that seems very practical to me. like going past like
I don't think we should have.
It seems very unlikely that your program's UB-ness or not depends on something that is more than 5 reference layers deep, right? But it seems very reasonable to imagine that it is 1 or 2 deep, right?
It seems very hard to reason about for people.
I mean, I'm not thinking about this tool as being something that I care about reasoning about. I think about it in terms of how easy it is to use it and get useful results from it, right?
Oh, I was thinking of.
But I mean, when somebody writes unsafe code, they also have to reason about it informally, at least, right? So reasoning isn't just relevant for researchers.
Oh no, I meant in terms of what properties Miri would be checking, not which ones we would actually say for unsafe code. Like,
I was talking about the.
I would like to have very good arguments every time we make this not the same thing.
I'm sorry, I think I missed that. Can you say that again?
I think we should basically have very good arguments every time we make what Miri checks and what we make the spec not the same thing.
Yeah, definitely.
I mean, I think okay. I mean, I think that it doesn't require a very good argument to allow making something configurable. Like if you're concerned that something is going to have a performance cost, it seems like an obvious resolution to me to like allow you to configure that.
Right.
Like especially if you imagine that there exists a reasonable configuration that will supply the thing that most users like, that will solve most users' problems in practice.
I think we need more data.
I think we can all agree that being pretty clear about what things Miri can check and what it cannot from the spec, good, and that like anything else, the better. Like if we can justify why each deviation exists, we should do so.
Right, but I guess my point is that I don't want to say something like, oh, we don't want to add recursive validity checks through references because we think that it'll be hard or expensive for Miri to check them. Because, I mean,
Right.
that seems
Consider
sort
that
of
a good
like a
enough
silly
reason,
thing
sort
to
of.
me.
To me, this seems like a perfectly reasonable argument.
Okay, yeah, so I don't agree with that at all. But like, we should.
But I think perhaps we should.
I mean, we may encounter an instance of this argument when we talk about NLL a little bit.
Yeah, I think perhaps we've been at this for 40 minutes, so maybe we should.
Yeah, probably we should turn to NLL. I feel like we've got enough for us to chew on. Like there's plenty of interesting stuff to bring back to the group.
Yeah,
Yes.
and let's continue with this.
And the last bullet is something we can probably discuss on GitHub. I guess if Taylor, if you have some more links or something for where that discussion that you mentioned happened, I think you had a link.
You were talking about the conversation with Esgriff about, I mean, you can look at the previous Variadics generics RFCs. I can link you to specific ones, but I'd probably be most efficient to just, I can explain. It's like a 2-sentence explanation. So.
Okay, fair, yeah.
I will take care of that. All right. I'm going to turn over to you then. Or no, turn over to me. Okay. So we were going to turn to the triage part of the meeting.
Yes.
Talk about these nominated PRs.
So it's basically the same issue. The one blocks the other.
Right. I think this is the one that y'all. Does someone want to present this?
Felix?
Briefly.
So yeah, the summary I can give right now is that we've got this pull request that implements a restriction on two-phase borrows in order to meet a constraint that Ralph wants to impose on the static semantics, or dynamic semantics, I guess. His desire for a particular dynamic semantics in Miri is leading to a constraint in the static semantics. And there has been some contention about whether this constraint is acceptable.
Right.
We do not, put another way, we do not presently have a good way to model the current two-phase borrows behavior, right?
Yes,
we wanted a conservative static check.
Imagine there have been several proposals, but it's
Agreed.
there's kind of an expressiveness cliff between the two-phase borrows we have and the one I thought we have and the one that's currently implemented in Miri. And this wasn't realized when implementing them, that there's actually like a meaningful difference in power. At least that's my understanding from talking with you guys, that there's actually a meaningful difference in power between what we currently have and what we would have after this PR. So I'm not saying we shouldn't have that other power. I mean, I'm actually quite surprised that this is at the turn this took, but basically I was saying maybe we could try to be more deliberate about this, and that was a week before stabilization, but of course, like, it was way too late to change anything. And I guess currently we are trying to figure out what the best way is to like be more deliberate about how we make it more powerful or not, and but understanding better what these extra powers are.
So, what implications does this have for, say, validity? Does it have any?
It's not really related to validity.
Right.
It's only about stack power. It's only about like in which references are you allowed to use in which order to do what.
Right.
So this is something where if we continued working at it, there are some spitballed proposals to model this. It's more a question of we don't yet know how or if we will be able to formally model the current behavior, and in the meantime we have a model for a subset of the current behavior. Is that accurate?
Yeah, so the model for the subset of the current behavior is trivial. It's a very trivial extension of NLL without two-phase borrows.
Right.
It's less than 10-line diff in MIRI. This extra thing is a huge extension. It's much bigger. It's a much bigger step from two-phase borrows, the restricted two-phase borrows, to the full two-phase borrows than from no two-phase borrows to restricted two-phase borrows.
And speaking of like performance and dynamic checks, how does this impact performance in a?
Well, we don't have an agreed upon like canonical model for the extension. That's the other thing. There's various ways you could model this, and there's a lot of ways you could make two-phase borrows even more powerful, and it's entirely unclear where this is supposed to go.
But
if
we take some of the models which you have considered, what implications would those have? If we,
I mean, I haven't implemented it, but one of them makes the tags 3 times as big, so it'll be a huge increase in like what is already the biggest contributor to memory consumption in MIRI, and I guess that would also be part of the performance thing.
right.
One would be trivial for performance, and would enable all possible extensions of two-phase borrows that are sound, I think, but it would also be the most pessimistic in terms of the compiler being able to analyze everything. It would basically mean two-phase borrows allow aliasing mutable references.
A question?
Yes?
So would it be possible to have a model that, are there models on the table that are less expansive in what two-phase borrows can do and are closer to modeling the current behavior, not an expansion of the current behavior?
I think all of them will...
a model that we can use that is slightly bigger than the current behavior, but we could limit it by saying this is what you're actually allowed to do, even though the model might allow more?
I think all of them allow extensions of the current behavior, and I haven't. I mean, this started kind of when my internship ended, so I haven't spent a lot of time trying to understand what exactly the envelope of allowed behavior of each of the proposed models is. But I think all of them would allow significantly more than what two-phase borrows currently allow, but I don't know how much.
Yeah, there's a fair number of ad hoc restrictions on the current implementation of two-phase borrows, just because the summary is we didn't want to have users depend on the mere code gen details. So we were trying to sort of come up with a set of restrictions that made it as close to the original source code in terms of what you would mentally model in your head as what's happening here.
I think it's...
when you say, sorry.
No, go ahead.
Question to make sure I understand. When you say that they all allow significantly more, Ralph, you mean sort of modulo the behavior that, like what two-phase borrows allows today includes this one case in which we have a pre-existing borrow, right? I guess we should maybe write that out too, right? The case in question is like you borrow something and you, with a two-phase borrow, I guess it would be best represented with a method call.
Yeah, I usually just write ampersand to mut or something.
Something like this, right, where this is doing a mutable borrow, the call to X, and now we're using this reference that pre-existed the mutable borrow. So you're saying apart from that, if you exclude that, then they're all significantly more permissive than two-phase borrows?
No, if you exclude that, then MIRI implements that, and it's a trivial extension of not having two-phase borrows. It was literally...
So we're only talking about this full...
Like less than an hour of work to... It was literally less than an hour of work to add two-phase borrows without that part. It was easy. But that part makes a huge difference. And the models that are supposed to handle that part are the ones that they allow a lot more. They allow, you're creating multiple two-phase borrows, and then you activate one of them but can't use the other anymore. And then they open questions about what if you have two-phase borrows created from a two-phase borrow, like nested stuff, and how does this activation work on trees and things. And all of these questions that we don't even really want to answer, but they naturally come up if you try to actually want to define something reasonably coherent.
So the actual proposal at hand, right, is to introduce a future compatibility warning for this case, which I believe we already have a number of future compatibility warnings due to the transition to NLL, where we basically closed a lot of bugs, essentially. And so this would be sort of rolled into that general set of warnings.
Yes, basically this would be viewing the fact that we allowed this as a bug, as in like we accidentally made two-phase borrows more powerful than we intended to.
Yes.
And then being more deliberate about extending it.
Right. And so just in case, I don't know if that, does everyone knows like already that we had all these warnings and that we planned to migrate after some time them to errors in any case.
Yep.
Yep.
And in particular, this affects all additions equally.
So I think so two things. At least when we discussed this originally, it was clear to me at least that we would treat this as a bug, and it seemed clear to me that there would be some regressions. That seemed inevitable. But I think it's rather easy to fix, and people will just naturally do it over a warning period. It could be like, it doesn't have to be very, very quick. It could take some time. I think it's entirely feasible to change this. And I think it's important that we do it because it's an important part of the language. It's not some, oh, we made a mistake in some attribute or something. It's a fundamental part of both the static and dynamic semantics of the language.
Important. It's the repercussions.
I mean, I guess then there's the other view is to say that we want to allow this probably anyway, and hence we should basically, like, eventually somebody will propose a model that's more or less reasonable that handles this, and until then we consider this a bug in the model and not a bug in the compiler.
Right. But
we don't know whether or not such a model exists, right?
Oh, I'm pretty sure models exist. The question is if we are happy with them.
Right.
Yeah,
Well, I mean, I'm sorry. The question is whether or not a model exists that both meets the expansibility needs of this expanded version of two-phase borrows and gives us room for the compiler optimizations we want.
Right.
Yes. The effect. I have even less of an idea of what the effect of these various models and optimizations would be. I think this is an intuition-only statement that the effect would only be on code that actually creates two-phase borrows, which I'm not sure if that's like helping or anything, but it shouldn't have an effect on code that only uses mutable and shared borrows.
What I think is important is that we have time to consider this, and the earlier we do it, the better. We were supposed to do a point release that didn't happen, and so we got more regressions. But if we delay, this will only get worse.
Yep.
I'd like to hear from Josh, I think, but I feel like you represented a pretty distinct opinion on the PR, Josh.
I do feel like we have Crater for a reason, and it's the tip of the iceberg. We see that this is breaking real existing code, and that shows that there are people who want to use the model that this allows, as opposed to a stricter model that would not allow this. And we have to assume that if we're seeing breakage on Crater, there is potentially more breakage we're not seeing. We have very strong stability guarantees. We don't do regressions in stable. And at the end of the day, I feel like the model is there to model the language we have, not to change the language to be more modelable.
I
would agree with one part of that. The first regression that we discovered, the first piece of code that we found in the wild that violated the model was code I wrote as part of the implementation of the model. I didn't write that code because I wanted the model to be more strict. I wrote that code because I was just writing code with references and didn't think much about it, and the compiler didn't complain. If it had complained, I would have changed the code a bit. So I wouldn't read this as intent that people want one model or the other. Code that happens and then it works. Why would you change it?
I think, though, that I recognize Josh's point, which is that, like, the fact that you wrote that means that that was an intuitive thing for you to write, and that the more that we can allow people to express intuitive things that are intuitive to them in the language and not give them compiler errors for those things, like, that's sort of better in a sense, right?
I agree. I agree that this is being able to do this is nice. I just want to do it in a deliberate manner and not just oops.
Yep. Yeah, I agree. I think that we should only decide to do this and allow this after we've found a way to model it and make sure that it's something that we want to allow in the language, right, rather than having it fall into the language not being the result of a conscious decision.
So I certainly think that would, past tense, have been a good thing to do. So and Josh, perhaps this is an argument that in the future, when we're introducing changes of this magnitude, we should have a model before letting the change in. I don't know. This was certainly one of the major flagship features of the 2018 edition, and it may well be there was a timing issue here of maybe we should have, waited until we had a model. But this is in stable Rust at this point.
I think you're doing... Oh, sorry, go ahead, Felix.
I feel like this rejection of even the idea of a gradual shift seems too, not stringent, what's the word? Too ironclad? It's something where the thing that was cratered was this hard error form. And since then, I've revised this PR to use a lint. And that provides a very easy way for someone to gradually adjust to the change in semantics. And I think the reality is, over time, we're gonna want to adjust the semantics of things.
I mean, we certainly have plenty of precedent for, I would say a couple of things. We have a lot of precedent for fixing bugs and trying to migrate people. And we've always taken a position of stability, should mean stability in practice. But we also have always taken a position, and we have an accepted RFC about the sort of need for us to become more and more strict with a model, and the recognition that doing so does sometimes may require changes around the edges. I definitely agree that, and I think we should start to develop, I think we should consider strongly our processes in light of this controversy, because I'm very sympathetic to what Josh is trying to say. But I also think there's a lot of precedent for making these sort of changes, and it feels like the damage here is not so high, and it feels like the gains to me are very large potentially, in that getting a model that actually gives room for the optimizations we want and is reasonably comprehensible and can be implemented efficiently is like quite a coup. And we seem to be on the cusp of it. I'm wary of throwing it away over the fact that there are 3 crates on crates.io that will get warnings for
I also want to Sure, go ahead.
Go ahead.
I want to emphasize that I don't feel I ever consensed to having this unstable. Like if I was aware that if there were regressions we wouldn't do this, I would never have allowed NLL unstable. Like this feels to me like there was a discussion that we would regard this as a bug, and we never signed off on this being really stable.
It is worth noting that we actually have an accepted RFC saying that accidentally stable features aren't actually stable.
Exactly.
Yeah, that's another piece.
That's the only reason I think this is even under consideration at all. If this were, anything other than an accidental, we didn't necessarily intentionally include this particular thing in our model, then I think we wouldn't even have something to discuss. It's like, this is a stable regression, closed.
Oh,
I don't agree with that.
The fact that we're talking about it at all is the fact that we're not necessarily saying this was a deliberate behavior of NLL, and we're debating the model.
So Josh, maybe it's too much dive into this conversation now as part of this like more focused discussion. But I think I disagree pretty strongly with your model of like stability, and I think that there are a lot of changes that we make that break people in practice in more significant ways than things like this, and that are allowed under our stability guarantees.
Yeah, absolutely.
And
unfortunately,
I think that like there are a lot of things like adding methods to traits, for example, that break tens of crates or hundreds of crates that we have still done historically. That's like really valuable.
We have an explicit stability statement that says this aspect of inference is something we explicitly do not consider stable. We have stated it.
But in terms of what that means to practical users, like the fix for me there and the fix for me here are not like especially meaningfully different from like the standpoint of like users who have to adjust their code over. Like I care how easy it is and how many occurrences I have to fix, right? It doesn't matter if errors due to inference or whether there was a bug in the compiler that happened to land unstable, right?
And I think in this case there are few regressions and it's easy to fix. I mean, you remove the let finding and do small tweak, and it's
I don't know how easy it will always be to fix in practice. We've looked at a lot of toy examples. That said, we have I want to be clear on one thing. I'm not trying to suggest an absolute hard line, we can't ever do this, period. I think what I'm more getting at is we seem to have come up on, here is a convenient model and it would require us to break this code. If we're going to consider making a deliberate decision to break that code, then I feel rather than going that route, we should say, here is another model that does fully encompass this code. Here is what optimizations that model would not allow us to make. Let's actually see both sides of the trade-off rather than saying, well, we have one model and it seems to work and it would require us to break this code, FCP.
So, Josh, I think that's really beneficial.
I don't even see how hard it would be to do this.
So, Josh, I think that's really true, and that's would be a really beneficial conversation to have, and I think everybody here wants to have that conversation, but we can't have that conversation while code is sitting and while we're allowing people to write new code that could potentially be broken in the future, right? Because the longer we leave this around, the harder it gets for us to make this an error. And so if we can make it an error now and then have that conversation about whether we want to allow this code or not, like we don't even ever have to make it a hard error. We could only ever have it as a future compatibility lint, and then we could decide, oh, actually we came up with a model that works, right? But for where we are right now, we have to introduce a future compatibility lint if we want people to not write more of this code.
Yeah.
So one other possibility there, rather than a future compatibility lint, I mean, part of the issue with lints is normally we use them to say, hey, there is something wrong with what you've done here. Here we're just saying, we're having a problem modeling what you've done here. So I think what I'm suggesting is, could we have the lint be something along the lines of, with the model we have, we may not be able to optimize this. Here's how you could change it to be more optimizable. And then we start figuring out, okay, could we optimize based on this or not? If there's a missed optimization opportunity, people might want to hear about that, and that's still a warning, not an error.
I think that the warning, as it's phrased as a future compatibility. Oh, sorry, go ahead, Ralph.
It won't be an misoptimization opportunity just in code that exploits this extra thing, because that would be like, it would be a difference in the model, which would mean unsafe code could rely on that kind of stuff happening. So it would be a misoptimization opportunity in every single piece of code that uses two-phase borrows. I don't think this lint doesn't classify in any way the code that gets less.
So here is my suggestion. Let's do the normal future compatibility lint with the issue and the warning and so on and so forth, and let's phrase the message in a sense that we are not sure, we might support this in the future, but
so I think the typical phrasing of future compatibility lints is, this may become a hard error in a future release, right? Which is appropriate.
No, it's actually phrased that this will become a hard error in the future. So there's a distinction.
Well, so maybe we swap out will for may or something. Yes. I don't know.
We could do that. I just wanted to say that we can also be, with the text we put in the issue that we link to can give a lot more context. We're not going to be able to put so much context into like an actual compiler error message.
Yep.
One thing I wanted to propose that I thought a compromise path here also might be just to do what Central suggested, but also start to write up rules to try to prevent this sort of thing from happening in the future and hold ourselves to them. I don't know. I first
we need a better model for what happened here so that we're not treating it as a one-off.
Yes.
Right, I mean, I feel like, yes, yeah.
One other thing, we're sort of out of time, but one other point that I would make is that let's never make such a big decision with such a like hard deadline and cutoff time.
Yeah. The addition was the timing decisions related to the addition. We have a lot more warning for the next edition. Let's stop making calls on what's in it and what isn't in it in like 2020.
Yeah.
I agree that, yeah, I would like to do a
Edition
on this particular thing. I think about how we can adjust our process. But
I think the way to do that is that you don't make the edition a flagship release, but that sort of defeats part of the point of it from a marketing perspective, right?
I just think that we need to be not do so big things so close to the deadline.
Agreed.
Right, but if the point of it is to market, we just did a bunch of big things, then you're taking that away, which is like, I think that's a reasonable position, but that's like the consequences of that is that you don't have that marketing opportunity.
Yeah, I get what you're saying. That's a very hard trade-off.
They're not time-based editions or something, but now we're getting into a totally different discussion.
Yeah.
I propose we table this particular discussion, which is a fair.
Does the lint, as phrased, the proposal work for you, Josh?
I think I'm not seeing the urgency to kill this immediately rather than saying what is the model that would encompass this and what is the problem with that model. In the absence of an alternative that we can hand people, I would prefer to just say, well, this code works right now and the compiler is handling it just fine.
You keep saying kill, but we're not, I mean, it's just a lint.
It's a lint saying we're going to break this in the future.
You don't understand why it would matter that more stable code accumulates. I mean, it feels like we're effectively making...
No, I understand what you're saying. We have one. One is infinitely worse than 0. What's 1 versus 5 versus 10?
What?
We can fix them if there's 10 or 20 of them as easily as one of them.
I don't agree with that at all.
No, I don't.
Hang on, no, I think that's I very, very, very much disagree with that attitude about this.
It's literally 6 minutes over and there's another meeting that has started 6 minutes ago.
Oh, sorry.
We're going to have to call it, but I definitely don't agree with that.
Yeah. Numbers make a whole lot.
All right. Well, thanks, everyone. This was a cool experiment.
Bye.
Yes.
Bye.
Thanks all.
Thanks.
Now, if I can figure out how to quit Zoom.
Yeah, thank you, Ralph, for joining.
Well, thank you all for discussing these crazy models with me.
Oh, you're still here. You dropped out of...